Winning a tennis match, a victorious player, Michael, smashed the ball vertically into the air at 27.5 meters per second. In this example, air resistance can be ignored and the acceleration due to gravity will be taken as 9.8 meters per second. Determine the maximum height reached by the ball. First thing, we draw a diagram. So we want to know this maximum height. So which of our SUVAT letters does that represent? S. We want to know S. We don't know that maximum height. We know that he's hit the ball upwards at a speed of 27.5 meters per second. Now I've just realised that if he's hitting the ball vertically at 27.5 and gravity is 9.8, one of those two has to be negative. That should have been in this problem.
Should gravity be negative too?
I think we should make gravity negative. Okay, so what do we know? Well, first of all, we want to know S.
We know V and U.
We know V and U. We do. And we know A. Okay, so here's the thing. What's U? What's our initial speed? 27.5. So our initial speed is 27.5 meters per second. Our final speed. Now this is the maximum height the ball reaches. If you think about a ball traveling upwards, when it reaches its highest speed, what's its vertical, its highest point, what's its vertical speed? Zero. It stops in the air for a split second and there is no vertical velocity. Okay? So anytime you do a problem like this, and you will do many of these, if you are looking for the highest point it reaches at that time, its velocity is zero. So our final velocity, our V, is zero. So we are looking for S. Okay? Again, we need to find a formula that uses all four of those, and we come up with V squared equals U squared plus 2AS. Okay. So, I should have made A negative, sorry. Okay, so V squared is 0. That's equal to 27.5 squared. I'm going to move my diagram over a little. 27.5 squared plus 2 times negative 9.8. We want S times S. Okay, so if we rearrange, we get 19.6 S is equal to 27.5 squared, which is 756.25. Now, if we divide both sides by 19.6, we get S is equal to 38.6 meters. That sounds about right.
What if you got a negative answer?
If you got a negative answer,
Yeah, what have you done?
Is your acceleration negative?
Yes.
And when you moved it to the other side, did you add it to both sides?
No, I didn't change the sign.
Okay, so remember, if you are moving this bit over here, you need to change the sign because you're adding this to both sides. To cancel it out there, you need to put it in there. So yeah, if you move it to the other side, you have to change your sign.
Yeah, that should be negative 2AS.
Cool. Okay, so there's how we get our maximum height and calculate the time that the ball takes to return to its starting position. Here is the other thing about projectile motion. If it goes up and reaches its maximum height and then goes back down to where it started, both of those journeys, both up and down, are exactly the same amount of time. Okay, you can assume that. If it starts at 0 and goes up, if it starts at something and goes up and hits 0, then comes back down, exactly the same time for both journeys. Both of those journeys are mirror images of each other. So if you get a question like this, calculate the time until the ball lands or returns to its starting position or anything like that, you find the time it takes to reach its maximum height and just double it. Okay? That is something you can assume. The path is a mirror image, up and down. So, calculate the time the ball takes to return to its starting position. We want to know time. We know V. We know U. And we know A. And this is my favourite when we have these four letters because you can use the easy equation. V equals U plus AT. So 0 is equal to U, 27.5, plus our acceleration is negative 9.8 t. Right, so if we're moving the t over to the other side, we need to change our sign. So we get 9.8 t is equal to 27.5. So therefore t, divide both sides by 9.8, 2.81. 2.81. Are we finished? No. We've got to double it. Okay, we need to double it. So that's how long it takes to get through one leg of its journey. So to get from the bottom point up to the top point, that is 2.81 seconds. So to get back down again, we just need to double that 2.81. Which is 5.62.